Hello everyone, and welcome back to Snoozing Scientist. Tonight we're going to take a journey far beyond the Earth. Beyond the clouds, beyond the moon, past the distant planets of our solar system, and out into the enormous darkness between the stars. We're going to explore one of the most fascinating questions humans have ever asked. Are we alone in the universe? Before we begin, feel free to leave a comment down below and let us know where you're listening from tonight. I always love seeing how far these quiet science journeys travel around the world. Now take a slow breath, get comfortable, and imagine yourself looking up at the night sky. On a clear night, far from city lights, the sky is filled with thousands of tiny stars. They appear small and distant, like scattered grains of light across a dark ocean. But each of those stars is a massive burning sphere of gas, many of them far larger than our own sun. And around many of those stars, planets are quietly orbiting. For most of human history, we didn't know this. Ancient civilizations looked up at the stars and wondered if other worlds existed out there. Philosophers imagined distant lands in the sky, places where life might exist under alien suns. But for thousands of years, those ideas remained only speculation. Then, in the 1990s, astronomers made an extraordinary discovery. They found the first confirmed planet orbiting another star. Since that moment, our understanding of the universe has changed dramatically. With increasingly powerful telescopes, scientists have discovered thousands of these distant planets, known as exoplanets. Some of them are enormous gas giants larger than Jupiter. Some are rocky worlds similar in size to Earth. Others are strange planets unlike anything in our own solar system. Worlds made mostly of water, planets with thick clouds of hot metal vapor, and planets that orbit so close to their stars that their surfaces may glow red with heat. The universe, it turns out, is filled with planets. And where there are planets, there is always the possibility of life. One of the most important ideas scientists consider when searching for life is something called the habitable zone. This is the region around a star where temperatures might allow liquid water to exist on the surface of a planet. Water is essential for life as we understand it. Every known organism on Earth depends on it. If a planet orbits too close to its star, water evaporates into space. If it orbits too far away, water freezes into ice. But in the habitable zone, conditions might be just right. Astronomers have already discovered several planets that exist within these zones. Some of them are only slightly larger than Earth, orbiting small red stars many light years away. One famous system known as TRAPPIST-1 contains 7 planets, several of which orbit within the star's habitable zone. These worlds circle their small, dim star in tight orbits, completing a full year in just a few days. If you could stand on the surface of one of those planets, the sky might look very different from ours. Instead of a bright yellow sun, you might see a deep red star glowing gently above the horizon. Nearby planets might appear large in the sky, sometimes even visible as glowing worlds drifting slowly overhead. It would be a sky unlike anything we see on Earth. But the search for life is not limited to distant stars. Even within our own solar system, scientists are discovering places that might support life beneath their surfaces. One of the most intriguing is a moon orbiting Jupiter called Europa. From a distance, Europa appears smooth and bright, covered in ice that reflects sunlight back into space. But beneath that frozen shell, scientists believe there may be an enormous ocean of liquid water. This ocean could contain more water than all of Earth's oceans combined. Deep beneath the ice, the ocean might interact with warm rock from the moon's interior. If hydrothermal vents exist there, similar to those found on Earth's deep ocean floor, they could provide energy and nutrients for simple life forms. Some scientists imagine microscopic organisms drifting slowly through Europa's dark ocean, surviving in an environment completely hidden beneath kilometers of ice. Another moon, Enceladus, orbiting Saturn, has revealed something equally fascinating. Spacecraft studying Enceladus observed giant plumes of water vapor erupting from cracks in the moon's icy surface. These plumes shoot enormous jets of water and ice particles into space. Inside those plumes, scientists detected organic molecules, the building blocks of life. The discovery suggests that a hidden ocean beneath Enceladus may also contain the conditions necessary for life. Far beyond our solar system, telescopes continue scanning distant stars, searching for signs that might indicate living worlds. One method involves studying the atmospheres of exoplanets. When a planet passes in front of its star, some of the star's light filters through the planet's atmosphere before reaching our telescopes. By analyzing that light, scientists can detect the chemical composition of the atmosphere. Certain gases, like oxygen and methane, can sometimes indicate biological activity. On Earth, these gases are produced in large quantities by living organisms. If astronomers ever detect a similar chemical signature on a distant planet, it could be one of the first signs that life exists beyond our world. But the universe is unimaginably large. The Milky Way galaxy alone contains hundreds of billions of stars. And beyond our galaxy lie billions more galaxies scattered across the cosmos. If even a tiny fraction of those stars have planets with the right conditions for life, the universe may be filled with living worlds. Some of those worlds might host simple microscopic organisms. Others might support complex ecosystems. And somewhere, perhaps very far away, intelligent beings might be looking up at their own night sky and asking the same question we ask. Are we alone? For now, we do not know the answer. But every year, new discoveries bring us closer to understanding the vast and mysterious universe we live in. Telescopes grow more powerful. Space missions explore distant moons. Scientists continue searching for subtle signs of life hidden within the light of distant stars. And somewhere out there, beyond the quiet darkness between the galaxies, countless worlds continue orbiting their stars, waiting to be discovered. As you imagine those distant planets tonight, picture them drifting silently through space. Some may be frozen worlds beneath faint stars. Some may be oceans stretching across entire planets. Some may have skies filled with strange colors and unfamiliar constellations. Each one is a possibility. A reminder that the universe is far larger and far more mysterious than we once believed. And perhaps, somewhere out there in the quiet darkness between the stars, life has already begun its own story. And when scientists think about the possibility of life beyond Earth, they often begin by looking at something very familiar to us. Life on our own planet. For billions of years, life has existed here in extraordinary forms, adapting to environments that once seemed impossible for living organisms. There are microbes living inside boiling hot springs, bacteria thriving miles beneath the Earth's surface, and organisms drifting in the deepest, darkest trenches of the ocean. These discoveries have slowly changed the way scientists think about where life might exist. Life, it seems, is incredibly adaptable. Because of this, the search for alien life is no longer limited to places that look exactly like Earth. Instead, scientists now study environments that once seemed far too extreme for living things. On Earth, for example, there are microorganisms known as extremophiles. These tiny organisms can survive in places where temperatures rise above the boiling point of water, or where the environment is so acidic that it would quickly dissolve metal. Some extremophiles live in frozen Antarctic lakes sealed beneath kilometers of ice, surviving in darkness and cold for thousands of years. If life can survive in these environments on Earth, then similar organisms might exist on other worlds as well. One place scientists are particularly interested in is the icy moon Europa. Beneath its frozen crust, there may be a vast ocean of liquid water. The gravitational pull of Jupiter creates gentle tidal forces inside Europa, flexing the moon's interior and generating heat. That heat may keep the ocean from freezing completely. If hydrothermal vents exist along the seafloor of Europa's hidden ocean, they could provide the same chemical energy that supports life in Earth's deep-sea vents. In such an environment, microscopic organisms might drift through the dark waters, feeding on chemical reactions rather than sunlight. Another fascinating place is Saturn's moon Titan. Titan is unlike any other world in our solar system. Its atmosphere is thick and hazy, composed largely of nitrogen with traces of methane and other organic molecules. On its surface lie lakes and rivers, but they are not made of water. They are made of liquid methane and ethane. In Titan's extremely cold environment, these hydrocarbons behave somewhat like water does on Earth, forming clouds, rain, and flowing rivers. Some scientists have wondered whether entirely different forms of life could evolve in such conditions, organisms that use liquid methane instead of water as a solvent for life's chemistry. If such life exists, it would be completely different from anything we know on Earth. The universe may hold many kinds of biology. Beyond our solar system, astronomers continue discovering strange new planets that challenge our imagination. Some planets are known as super-Earths, rocky worlds larger than Earth but smaller than gas giants like Neptune. These planets may have thick atmospheres and enormous oceans stretching across their surfaces. Others are ocean worlds, planets that may be completely covered in water hundreds of kilometers deep. In such worlds, continents might not exist at all. Instead, endless oceans could stretch from horizon to horizon, with unknown ecosystems evolving beneath the waves. Then there are planets known as rogue planets. These mysterious worlds drift through space alone, no longer orbiting a star. They may have been ejected from their original solar systems long ago during gravitational interactions with other planets. Without a nearby star, rogue planets receive almost no light or heat. Yet if they have thick atmospheres or internal heat from radioactive elements within their cores, it is possible that liquid water could exist beneath layers of ice. Even in the darkness of interstellar space, life might find a way to survive. The search for alien intelligence also continues quietly here on Earth. Large radio telescopes scan the skies, listening for unusual signals that might come from distant civilizations. This effort is often referred to as the search for extraterrestrial intelligence, or SETI. So far, scientists have not confirmed any signals that clearly originate from intelligent life beyond Earth. But the search continues, because the universe is unimaginably vast. The nearest star beyond our Sun, Proxima Centauri, lies more than 4 light-years away. That means the light we see from that star tonight actually began its journey toward Earth over 4 years ago. Many stars in our galaxy are thousands of light-years away. Signals from distant civilizations, if they exist, would take decades, centuries, or even millennia to travel between stars. In this sense, the search for alien life is a slow and patient process. Astronomers gather data, analyze signals, and slowly build a clearer understanding of the planets scattered throughout our galaxy. Every new telescope adds to that picture. The James Webb Space Telescope, for example, is capable of analyzing the atmospheres of distant planets in remarkable detail. By studying the faint light filtering through those atmospheres, scientists can detect gases that might indicate biological activity. oxygen, methane, water vapor. Each discovery helped scientists narrow the search for planets where life might exist. And with every passing year, the list of potentially habitable worlds grows. When you look up at the night sky tonight, remember that many of those stars are not alone. Around them, unseen planets may be orbiting quietly in the darkness. Some may be barren and frozen. Some may be covered in oceans or thick clouds. And some may be worlds where life has already begun its own quiet journey through evolution. Perhaps somewhere beneath an alien ocean, microscopic organisms are drifting through warm chemical vents. Perhaps on another world, forests of unfamiliar plants stretch across landscapes under strange-colored skies. And perhaps, on a distant planet orbiting a quiet star, another civilization may one day look up into the night sky and wonder about the same mystery. The possibility that somewhere out there, across the enormous silence of space, other forms of life may exist. Waiting, growing, and quietly exploring their own universe. As scientists began discovering more and more planets orbiting distant stars, a quiet realization slowly began to settle into the minds of astronomers. The universe might be full of worlds. And if worlds are common, then perhaps life is common too. After all, the Milky Way galaxy alone contains hundreds of billions of stars. Around many of those stars, planets orbit quietly, just as the planets of our own solar system circle the Sun. Some of those planets may be rocky like Earth. Some may have oceans. Some may exist in the gentle warmth of their star's habitable zone. When scientists began to think about these numbers, the possibilities started to feel enormous. If even a small fraction of those planets developed life, then the galaxy could contain millions, perhaps even billions, of living worlds. And if life sometimes evolves into intelligent civilizations, then the galaxy might contain other technological societies as well. Civilizations capable of building telescopes. Civilizations capable of sending signals into space. Civilizations that might wonder about the universe in the same quiet way that we do. But this idea leads to a strange and fascinating question. If intelligent life could be common in the universe, why haven't we seen any evidence of it? This puzzle is known as the Fermi paradox, named after physicist Enrico Fermi. During a casual conversation with colleagues in the 1950s, Fermi asked a very simple question. Where is everybody? It was not meant to dismiss the possibility of alien life. In fact, it was the opposite. Fermi was pointing out that if intelligent civilizations were common, then the galaxy might already be filled with their presence. Even a civilization only slightly more advanced than ours could, in theory, begin exploring neighboring star systems. Over millions of years, such exploration could spread gradually across the entire galaxy. Compared to the age of the Milky Way, which is more than 13 billion years old. Even a slow expansion could eventually reach every corner of the galaxy. So if intelligent civilizations have existed before us, if some of them developed space travel, if they explored the stars, then where are the signs of them? Why do our telescopes see only natural signals from stars and galaxies? Why have our radio receivers not clearly detected the voices of distant civilizations? Why does the universe appear so quiet? Scientists have proposed many possible explanations for this mystery. One possibility is that intelligent life is extremely rare. While simple life might emerge easily on suitable planets, the development of complex, technological civilizations could require a long chain of unlikely events. On Earth, life existed for billions of years before intelligence evolved in a species capable of building technology. Perhaps that step is far less common than we imagine. Another possibility is that civilizations simply do not last very long. Technological societies may face challenges that make long-term survival difficult. Environmental changes, resource limitations, or conflicts could prevent many civilizations from reaching the stage where they explore the stars. In this idea, known as the Great Filter, something prevents most civilizations from expanding far into the galaxy. That filter could occur early in the development of life, or it could appear later as civilizations become more advanced. Scientists do not yet know which possibility is more likely. But there are other explanations as well. It is possible that alien civilizations exist, but they are simply too far away for their signals to reach us yet. The galaxy is enormous. Even radio signals traveling at the speed of light can take thousands of years to cross it. A civilization broadcasting today might not be heard by us for many centuries. Or perhaps advanced civilizations choose not to broadcast at all. They may communicate in ways we do not yet understand, using technologies far beyond our current science. Some scientists even imagine that highly advanced civilizations might build enormous structures around their stars to capture energy. These theoretical constructions are sometimes called Dyson spheres. Rather than surrounding a star with a solid shell, a Dyson sphere might consist of millions of solar collectors orbiting the star, capturing its energy to power an advanced civilization. Such structures could change the way a star appears from far away, creating unusual patterns of light that astronomers might someday detect. In fact, astronomers have already observed a few strange stars whose brightness fluctuates in unusual ways. While natural explanations are usually the most likely, these discoveries remind scientists to keep searching carefully. The universe still holds many surprises. For now, the search continues quietly. Radio telescopes scan the skies, listening for patterns that might indicate artificial signals. Space telescopes analyze the atmospheres of distant planets, searching for chemical signs that life might exist there. Each discovery brings us a little closer to understanding whether life is rare or common in the cosmos. And perhaps, somewhere among the billions of stars in our galaxy, another civilization is looking out into space tonight as well. They may be studying their own stars and planets. They may be wondering whether life exists beyond their world. And just like us, they may be listening carefully to the quiet universe, waiting for a signal that tells them they are not alone. For now, the universe remains silent. But it is a vast silence. A silence filled with countless stars, countless planets, and possibilities still waiting to be discovered. The question of alien life does not end with distant planets or the quiet mystery of the Fermi paradox. In fact, the deeper scientists look into the universe, the more they begin to realize that life might not only exist on worlds similar to Earth. It may exist in places that seem almost unimaginable. For a long time, scientists assumed that life required conditions very similar to those on our planet: liquid water, moderate temperatures, and a stable environment beneath the warmth of a star. Earth appeared to be a perfect balance of many delicate factors. But over the last few decades, that idea has slowly begun to change. Researchers studying life on Earth have discovered organisms thriving in environments once thought completely inhospitable. Deep beneath the ocean floor, bacteria live within hot rock miles below the surface. In acidic lakes where the water burns like chemical acid, microbes continue to grow and reproduce. Some organisms even survive in places exposed to intense radiation that would quickly kill most life forms. These discoveries have taught scientists something important. Life does not always require perfect conditions. Sometimes it simply adapts. And because of this, many scientists now believe the universe may contain forms of life very different from anything we know. Imagine a planet orbiting a dim red star. The sky there might glow faintly crimson, the sunlight weak and cool. On the surface, strange plants might absorb this red light using pigments completely unlike chlorophyll. The landscape might appear dark purple or black, shaped by life adapted to a different kind of sunlight. Or imagine a world covered entirely by a deep global ocean. Without continents, enormous ecosystems might exist beneath the water, drifting slowly in currents that circle the entire planet. Creatures there might resemble Earth's deep sea life, glowing gently in the darkness as they move through the water. Some scientists even imagine life forms that use entirely different chemistry. On Earth, life is based on carbon and water. Carbon atoms form complex molecules that can build cells, proteins, and DNA. Water acts as a solvent that allows chemical reactions to occur. But on other worlds, different chemical systems might exist. For example, scientists studying Saturn's moon Titan have wondered whether life there could use liquid methane instead of water. Titan's lakes and rivers are made of hydrocarbons that flow across its frozen surface in temperatures colder than -170 degrees Celsius. In such an environment, life would not look like plants or animals. It might be microscopic, slow-moving, and based on chemical reactions we barely understand. Yet the basic principle of life, the ability to organize matter, store information, and reproduce, could still exist. Beyond chemistry, there is also the possibility that alien life might evolve senses and perceptions very different from ours. On Earth, many animals rely on sight, hearing, and smell to understand their surroundings. But these senses evolved under the conditions of our planet, its atmosphere, its oceans, and its sunlight. On another world, the environment might shape life in entirely new ways. Creatures might perceive magnetic fields as easily as we see color. They might sense electrical signals in the ground or navigate using faint vibrations in the air. Their experience of reality could be completely different from our own. And yet, across the enormous distance between stars, there may be certain universal patterns that life follows. Where energy exists, life may emerge. Where chemistry allows molecules to organize and replicate, evolution may begin. Given enough time, simple organisms may slowly become more complex. And occasionally, intelligence may appear. Intelligent beings might develop tools, languages, and technologies. They might begin studying their environment, just as we study ours. They might look toward the stars and begin to wonder whether other minds exist beyond their world. Perhaps somewhere in the galaxy right now, on a distant planet orbiting a quiet star, a young civilization is beginning to build its first telescopes. Their scientists might be mapping their own solar system, discovering neighboring planets and moons. And perhaps, one night, they may detect the faint signal of another world, a pale blue planet orbiting an ordinary yellow star. A planet we call Earth. For now, the universe keeps its secrets. The distances between stars are enormous, and the signals we send into space travel slowly through the cosmic darkness. Our radio broadcasts have only traveled about 100 light-years from Earth. A tiny bubble within the vastness of the Milky Way. But the search continues. New telescopes will soon look deeper into space than ever before. Future missions may send probes to the icy oceans of Europa or Enceladus. Astronomers will continue analyzing the atmospheres of distant planets, searching for subtle signs of life. Each discovery brings us closer to answering one of the oldest questions humanity has ever asked. Are we alone in the universe? Or are we simply one small part of a much larger story unfolding across the stars? As you imagine those distant worlds tonight, picture them drifting quietly through the darkness of space. Billions of planets orbiting billions of stars. Some silent and empty. Some perhaps alive with strange ecosystems. And somewhere, perhaps very far away, another civilization might be looking up at their night sky and wondering the same quiet question. Is anyone else out there? And in the vast calm of the universe, that question continues to echo gently among the stars. And as scientists continue thinking about the possibility of life beyond Earth, they often find themselves asking another quiet question. Not just where life might exist, but how it might begin in the first place. On Earth, life appeared surprisingly early in the planet's history. Our planet formed about 4.5 billion years ago, and the earliest signs of simple life may date back more than 5 billion years. That means life began not long after the Earth cooled enough for oceans to form. This has led many researchers to wonder whether the emergence of life might actually be a natural outcome of chemistry. In other words, when the right ingredients come together, water, energy, and complex molecules, life might arise almost inevitably. One idea that explores this possibility is called abiogenesis. Abiogenesis refers to the process by which non-living chemistry slowly organizes itself into living systems. Scientists believe that in Earth's ancient oceans, simple molecules may have gradually formed more complex structures. Over time, some of these molecules gained the ability to copy themselves. Once that happened, evolution could begin. Small chemical systems that copied themselves more efficiently would gradually become more common. Over millions of years, these primitive replicators could have evolved into the first cells, tiny living organisms that eventually gave rise to all life on Earth. But where did the ingredients for life come from? Some scientists believe many of them may have arrived from space. Meteorites that fall to Earth often contain organic molecules, the building blocks of life. These molecules can form naturally in the cold clouds of gas and dust that drift between stars. Over time, they become incorporated into comets, asteroids, and young planets. In this way, the early Earth may have been seeded with complex chemistry from the wider universe. This idea is sometimes connected to a broader theory called panspermia. Panspermia suggests that life itself, or at least the seeds of life, might travel between planets. Tiny microorganisms could survive inside rocks ejected by asteroid impacts, drifting through space for millions of years before landing on another world. If such a process occurs, life in the universe might spread slowly from planet to planet, carried across space by natural events. Though we do not yet know if panspermia truly happens, experiments have shown that some microorganisms can survive the vacuum of space for surprisingly long periods. The universe may be more connected than we once imagined. Beyond the origins of life, scientists also think about how alien civilizations might develop technology. On Earth, technological progress has accelerated rapidly over the last few centuries. In just a short time, humanity has moved from simple mechanical machines to computers, satellites, and spacecraft capable of exploring other planets. If another civilization followed a similar path, their technology might eventually allow them to manipulate enormous amounts of energy. This idea leads to the concept of civilization scales, often called the Kardashev scale. This scale measures how advanced a civilization is based on the amount of energy it can harness. A Type 1 civilization uses the energy of its entire planet. A Type 2 civilization might capture the energy of its star. And a Type 3 civilization could potentially harness the energy of an entire galaxy. Humanity, by comparison, is still far below even Type 1. We currently use only a small fraction of the total energy available on Earth. But imagining these possibilities helps scientists think about what advanced alien civilizations might look like. Such civilizations might construct enormous structures around their stars to capture energy. They might send self-replicating robotic probes across the galaxy to explore distant worlds. They might even modify entire planets to create environments suitable for life. Yet despite these possibilities, the universe remains quiet. Astronomers continue to listen for signals, analyze distant planets, and search for subtle signs that intelligent life exists elsewhere. And every year, our instruments grow more sensitive. The next generation of telescopes may be capable of detecting tiny chemical traces in the atmospheres of distant Earth-like planets. By analyzing the faint light passing through those atmospheres, scientists may be able to identify gases produced by living organisms. The discovery of such a biosignature would be one of the most important scientific discoveries in human history. It would mean that life is not unique to Earth, that the universe itself is capable of creating living worlds. And perhaps, somewhere beyond our view, intelligent civilizations may already exist. They may have developed their own sciences, their own cultures, their own ways of understanding the universe. They may have wondered about distant planets just as we do. They may have sent signals into space, hoping that someone, somewhere, might be listening. For now, the night sky remains quiet. But it is a quiet filled with possibility. When we look up at the stars, we are not only seeing distant suns. We are seeing countless opportunities for life, evolution, and discovery. And perhaps one day, somewhere among those distant lights, we may finally find the answer to one of humanity's oldest questions. Whether the universe holds other minds looking back toward us through the same vast sea of stars. And as the search for alien life continues, some scientists have begun to consider a quieter and more subtle possibility. What if intelligent civilizations rarely last very long? This idea is sometimes connected to what researchers call the Great Filter. The Great Filter is not a single event, but rather a series of difficult steps that life must pass through in order to become a technologically advanced civilization. Somewhere along this path, there may be obstacles so challenging that very few civilizations survive them. The earliest steps may include the origin of life itself. Perhaps the transition from simple chemistry to living cells is extraordinarily rare. Even if planets with oceans are common, the leap from molecules to biology may happen only occasionally across the universe. Another possibility lies in the development of complex life. For billions of years on Earth, life remained microscopic. Only much later did multicellular organisms appear, eventually leading to animals, plants, and ecosystems rich with diversity. The emergence of intelligence capable of building technology may be an even rarer step. And even if intelligent life evolves, there may be additional challenges. Civilizations might face environmental collapse, resource depletion, or technological dangers before they reach the stage of exploring the stars. Some scientists wonder whether many civilizations may simply fade away before they have the chance to communicate with others. This possibility adds a quiet sense of urgency to our own exploration of space. Humanity may be one of many civilizations trying to navigate these delicate stages of development. But there are also more hopeful ideas. Some researchers believe that advanced civilizations may become extremely quiet. Rather than broadcasting powerful signals across space, they might use communication technologies far more subtle than our current radio transmissions. Their signals might be compressed, encrypted, or transmitted in ways we have not yet learned to detect. In this case, the universe might not actually be silent. It may simply be speaking in languages we do not yet understand. Another intriguing idea is that alien civilizations might communicate through artificial megastructures rather than radio waves. For example, astronomers have proposed the concept of a Dyson sphere, a vast structure built around a star to capture a significant portion of its energy. Such a structure would not necessarily be a solid shell, but perhaps a swarm of satellites orbiting the star, collecting its light. From a great distance, a star surrounded by such structures might appear dimmer or behave in unusual ways. Astronomers sometimes look for these strange patterns in the light of distant stars, wondering whether they might hint at advanced engineering far beyond our own capabilities. There are also theories suggesting that alien life might exist not on planets at all, but in environments very different from the surfaces we are familiar with. Some scientists have imagined life forms drifting within the thick atmospheres of gas giant planets. These hypothetical organisms might float through layers of clouds, carried by warm currents rising from deep within the planet's interior. Others have suggested that life could exist inside the oceans hidden beneath the icy crusts of moons like Europa or Enceladus. Beneath kilometers of frozen ice, vast seas of liquid water may remain warm due to tidal forces generated by nearby giant planets. If hydrothermal vents exist in those hidden oceans, they could provide energy sources similar to the deep-sea ecosystems found on Earth. In such places, life might flourish in complete darkness, never seeing the light of a star. Still, other ideas reach even further into speculation. Some physicists have wondered whether life might arise within environments very different from ordinary matter. Hypothetical forms of life based on plasma, magnetic fields, or exotic particles have occasionally been proposed in theoretical discussions. While these ideas remain speculative, they remind us that our understanding of life may still be limited by our experience on a single planet. The universe is vast beyond imagination. Our galaxy alone contains hundreds of billions of stars, many with planets orbiting them. Beyond the Milky Way lie hundreds of billions of other galaxies, each containing their own systems of stars and worlds. If even a tiny fraction of those planets are capable of supporting life, then living organisms may be scattered widely across the cosmos. Some worlds may host simple microbial ecosystems. Others may contain forests, oceans, and complex creatures shaped by alien evolution. And perhaps, on a few rare planets, intelligent civilizations may arise, civilizations that look up at their own skies and wonder about the same mysteries. For now, we remain explorers at the very beginning of this search. Our telescopes are still young. Our spacecraft have only begun to reach the edges of our solar system. The signals we send into space have traveled only a short distance into the cosmic ocean. Yet with each passing year, our understanding grows. New missions will search the icy moons of the outer planets. Future telescopes will examine the atmospheres of distant Earth-like worlds. Advances in biology, chemistry, and physics may reveal new clues about how life emerges from the basic ingredients of the universe. And slowly, step by step, humanity continues listening. Listening to the quiet of the stars. Listening for a whisper across the enormous distance between worlds. A whisper that might tell us we are not alone. And as our understanding of the universe grows deeper, scientists sometimes consider a fascinating possibility. What if life in the universe does not only exist around stars, but also between them? The space between stars, known as the interstellar medium, is not completely empty. It contains vast drifting clouds of gas and dust called nebulae. Within these cold clouds, complex molecules are constantly forming and breaking apart under the influence of radiation and cosmic energy. Over the past several decades, astronomers have discovered surprisingly complex organic molecules inside these clouds. Some of them resemble the molecular building blocks that life on Earth depends on. These discoveries raise an interesting thought. Perhaps the chemistry that eventually leads to life does not begin on planets at all. Instead, it may begin slowly in the quiet darkness between the stars. Within these enormous molecular clouds, atoms of carbon, hydrogen, oxygen, and nitrogen can assemble into increasingly complex structures. These molecules may eventually become part of new solar systems when the clouds collapse to form stars and planets. In this way, every planet may inherit a rich chemical legacy from the interstellar space that existed long before it formed. In a sense, the seeds of life may already be present before a planet is even born. Another intriguing idea involves the role of time in the search for alien civilizations. The universe is incredibly old. It formed about 13.8 billion years ago, while Earth itself is only about 4.5 billion years old. This means that other planets in the galaxy could have formed billions of years before our own. If intelligent life evolved on those worlds, some civilizations might be far older than humanity. Imagine a civilization that began exploring space 1 million years ago. Or even 10 million. Over such immense stretches of time, their technology might become almost indistinguishable from natural phenomena. They might build structures the size of planets, or manipulate energy in ways we cannot yet imagine. Some scientists have even speculated that extremely advanced civilizations might eventually move away from physical exploration altogether. Instead, they might turn inward. They could create enormous virtual worlds, simulated environments where consciousness could exist in forms entirely detached from biological bodies. Their civilizations might become quiet not because they disappeared, but because their activity moved into domains we cannot easily observe. Another fascinating concept is that alien intelligence might not resemble biological organisms at all. On Earth, intelligence evolved through the nervous systems of animals. Our brains are biological structures made from cells and chemicals. But once a civilization develops advanced computing technology, it may eventually create artificial intelligence systems far more powerful than biological minds. If that process occurs elsewhere in the universe, alien civilizations might transition from biological life to machine intelligence. Such artificial minds could exist in environments inhospitable to organic life. They might operate in the vacuum of space, orbiting stars, or drifting through the galaxy aboard enormous computational structures. These machine civilizations might think slowly across centuries or rapidly across milliseconds. Their perception of time could be very different from our own. From their perspective, the universe might feel much smaller and more accessible. Another mysterious possibility involves cosmic communication methods far beyond radio waves. While humans currently rely on electromagnetic signals, advanced civilizations might use entirely different physical processes to transmit information. Some theoretical proposals suggest communication through neutrinos, tiny particles that can pass through entire planets without interacting with matter. Others imagine signals encoded in gravitational waves, ripples in space-time produced by massive cosmic events. If such technologies exist, they might allow communication across enormous distances without interference. Yet detecting such signals would require instruments far more advanced than those we currently possess. In addition to searching for signals, scientists also search for technosignatures, indirect signs of advanced civilizations. These might include unusual patterns of energy use, strange chemical signatures in planetary atmospheres, or enormous artificial structures orbiting distant stars. Even something as subtle as a planet glowing slightly brighter at night than expected could hint at artificial illumination on its surface. The search for these clues has only just begun. New telescopes, both on Earth and in space, are slowly expanding our ability to observe distant worlds. Instruments capable of analyzing the faint light of exoplanet atmospheres may soon detect molecules like oxygen, methane, or ozone, gases that on Earth are strongly associated with life. If such biosignatures are found, they would suggest that living ecosystems exist on another planet. And perhaps someday, even more intriguing signals might appear. A repeating radio pattern. An unusual star dimming in a way that cannot be explained by natural causes. Or a distant planet whose atmosphere contains chemical imbalances that only life could produce. Each of these discoveries would bring humanity one step closer to understanding our place in the universe. For now, we remain watchers beneath a quiet sky. Our telescopes continue scanning the stars. Our probes explore the planets and moons of our solar system. And our imaginations stretch outward into the immense darkness between galaxies. Somewhere in that vast cosmic ocean, other forms of life may already exist. Perhaps simple and microscopic. Perhaps vast and complex. Or perhaps intelligent beings looking up at their own night sky, wondering about distant civilizations they cannot yet see. And as the universe continues to unfold around us, the search for those distant neighbors remains one of the most profound journeys humanity has ever begun. As scientists continued to think about life beyond Earth, their questions slowly became deeper and more philosophical. The search was no longer only about finding microbes on distant planets or detecting radio signals from alien civilizations. It became something larger, an attempt to understand how life itself fits into the story of the universe. Some researchers began to wonder whether life might be more than just a rare accident. Perhaps, in some quiet way, the universe tends toward complexity. When the universe first began nearly 14 billion years ago, it was a simple place. There were no planets, no stars, and certainly no living organisms. There were only clouds of hot particles slowly cooling as space expanded outward in every direction. Over time, gravity began gathering matter together. The first stars formed, burning brightly and forging heavier elements deep in their cores. When those stars eventually died, they scattered those elements across space, enriching the cosmos with the raw materials that would one day build planets and living things. Carbon, oxygen, nitrogen, iron, the atoms inside our bodies were created in ancient stars that lived and died long before the Earth existed. In this sense, life is not separate from the universe. It is one of its natural outcomes. Because of this, some scientists suggest that life may be part of a larger pattern of increasing complexity. Stars form from clouds of gas. Planets form from disks of dust. Chemistry grows more elaborate over time. And eventually, in certain environments, matter begins organizing itself into systems that can copy, adapt, and evolve. If that pattern holds true across the cosmos, then life may not be rare at all. It may simply take patience. Billions of years of slow chemical experimentation unfolding quietly on worlds scattered throughout the galaxy. Another intriguing idea considers the possibility that life might evolve intelligence more than once on the same planet. On Earth, humans are currently the only technological civilization. But evolution has produced many other intelligent animals, dolphins, octopuses, elephants, and several species of primates. Each of these creatures shows remarkable problem-solving abilities and complex social behaviors. Some scientists wonder whether, given enough time, other intelligent species might eventually have developed advanced technology. If Earth's history had unfolded slightly differently, perhaps another species might have built its own civilization long before humans appeared. Extending that idea outward into the universe raises interesting possibilities. On distant planets with long stable climates, intelligence might evolve multiple times. Entire ecosystems of thinking species might coexist, each developing different tools, cultures, and ways of understanding their environment. Their civilizations might not resemble ours at all. Some might be cooperative networks rather than competitive societies. Others might evolve technologies based on biology rather than machines, growing structures instead of building them. In such civilizations, cities might resemble forests more than metal skylines. But perhaps the most fascinating possibility is that alien life might exist in forms we would struggle to recognize. Our understanding of life is shaped entirely by Earth's biology. We look for water, carbon molecules, and oxygen because those are the ingredients that sustain life here. Yet the universe contains many other environments. Some scientists have imagined life existing inside the clouds of gas giants, where enormous floating organisms drift through dense atmospheric layers, slowly feeding on chemical reactions within the clouds. Others have speculated about life in subsurface oceans buried beneath ice-covered worlds. In these environments, sunlight never reaches the water. Instead, life would depend entirely on chemical energy from hydrothermal vents deep on the ocean floor. There are even speculative theories about life composed of plasma within stars, or complex structures forming inside neutron stars under extreme physical conditions. While these ideas remain highly theoretical, they remind us that the universe is capable of producing environments far stranger than anything we experience on Earth. And somewhere within that diversity, new forms of life may exist. There is also the question of time. Human civilization has existed for only a few thousand years. An incredibly brief moment compared to the age of the universe. Our radio signals have traveled only about 100 light-years into space, barely touching the edge of our galactic neighborhood. Meanwhile, the Milky Way galaxy is over 100,000 light-years across. This means that even if intelligent civilizations exist elsewhere in the galaxy, they may simply be too far away for communication to have reached us yet. Two civilizations separated by thousands of light-years might both be sending signals, but those signals could take tens of thousands of years to arrive. In this sense, the universe may be filled with conversations that have not yet reached our ears. Messages drifting slowly through space, carried by faint waves of energy moving at the speed of light. Another possibility is that alien civilizations may deliberately avoid making themselves visible. Some scientists have proposed what is sometimes called the cosmic zoo hypothesis. According to this idea, advanced civilizations might be aware of younger species like humanity but choose not to interfere. Just as humans observe wildlife without disrupting natural ecosystems, an advanced extraterrestrial society might quietly watch developing civilizations from a distance. If this were the case, we might not notice their presence at all. Their technology could be subtle enough to remain hidden, blending into the natural background of the universe. Of course, these ideas remain speculative. The truth is that the universe still holds many mysteries. But as our instruments improve and our exploration continues, humanity slowly moves closer to answering these questions. Every new telescope reveals thousands of distant planets. Every new probe sent into space expands our understanding of the environments where life might exist. And every discovery reminds us that our planet is only a tiny part of an unimaginably vast cosmos. Perhaps somewhere, far beyond the stars we can see tonight, life has already taken many different forms. Simple microbes drifting in alien oceans. Strange ecosystems glowing beneath frozen ice. Or intelligent civilizations quietly studying the same universe we observe. And as we continue searching, one gentle realization begins to emerge. The universe may be far more alive than we once imagined. And our story within it may only be just beginning. As the scientific search for alien life has grown more careful and methodical, another thread of curiosity has quietly followed alongside it, a long history of mysterious sightings in the skies above our own planet. For centuries, people have occasionally reported seeing strange lights or unusual objects moving through the night sky. Long before modern aircraft existed, historical records from many cultures described glowing shapes drifting silently overhead, bright disks crossing the stars, or distant objects moving in ways that seem difficult to explain. In ancient Rome, historians wrote of burning shields seen in the sky during daylight hours. Medieval chronicles sometimes mentioned strange lights hovering above towns or moving slowly across the horizon at night. Most of these events were likely natural phenomena. Comets, meteors, atmospheric reflections, or unusual cloud formations. But as technology advanced in the 20th century, sightings began to take on a different character. Pilots, radar operators, and military personnel occasionally reported objects moving at extraordinary speeds or performing maneuvers that seemed beyond the capabilities of known aircraft. During the early years of the Cold War, when radar systems became more common, some of these objects were tracked electronically as well as visually. In 1947, a private pilot named Kenneth Arnold reported seeing a group of bright objects flying near Mount Rainier in Washington state. Arnold described their motion as similar to a saucer skipping across water, and newspapers quickly picked up the phrase. From that moment, the idea of flying saucers entered popular culture. Over the following decades, thousands of sightings were reported around the world. Some were later explained as weather balloons, experimental aircraft, satellites, or atmospheric effects. Others remained more difficult to interpret, often because the observations were brief or recorded under unusual conditions. Because of this uncertainty, scientists began using a more neutral term, UFO, or unidentified flying object. More recently, many researchers prefer the term UAP, which stands for Unidentified Aerial Phenomenon. This phrase reflects a broader approach, acknowledging that unusual events in the sky may involve atmospheric, technological, or observational factors rather than assuming a specific explanation. In recent years, interest in these phenomena has quietly returned to the scientific community. Several governments have declassified reports describing encounters between military aircraft and objects that appeared to move in unusual ways. Some radar recordings show objects accelerating rapidly or changing direction abruptly, sometimes without visible propulsion. In a few widely discussed cases, pilots described objects that seemed to hover motionless before suddenly moving at high speed. These observations do not necessarily mean extraterrestrial technology is involved. In many cases, researchers suspect that unusual atmospheric effects, sensor artifacts, or misidentified experimental aircraft may be responsible. But the events themselves remain worthy of study. Science often begins with careful observation of things that do not yet have clear explanations. Just as early astronomers once puzzled over strange lights moving across the sky, lights that we now understand as planets. Modern researchers continue investigating unexplained aerial phenomena with improved instruments and data analysis. The goal is not to jump immediately to extraordinary conclusions. Instead, scientists try to gather as much information as possible. Radar measurements, infrared recordings, satellite data, and eyewitness reports can all help build a clearer picture of what is actually occurring in the atmosphere above us. In many cases, the explanations turn out to be natural or technological. But occasionally, a small number of observations remain unresolved. For those studying the broader question of alien life, these mysteries serve as reminders that our understanding of the sky is still incomplete. After all, humanity has only been flying aircraft for a little over a century. Our instruments are still evolving, and our ability to observe the atmosphere and space beyond it continues to improve every year. Whether these sightings ultimately reveal new atmospheric phenomena, undiscovered technologies, or simply the complexities of perception and measurement, they remain part of humanity's ongoing curiosity about what lies beyond our planet. And perhaps that curiosity itself is the most important part of the story. When people look up at the night sky and notice something unexpected, a strange light, a sudden movement among the stars, it reminds us that the universe is still full of questions waiting to be explored. Some mysteries will eventually find ordinary explanations. Others may lead to entirely new discoveries about the nature of the world around us. But in the quiet hours of the night, when the sky stretches endlessly above the Earth, it is easy to understand why humans have always wondered what else might be out there. Watching, exploring, or simply drifting silently through the vast darkness of space. As the idea of alien life slowly moved from myth and imagination into serious scientific discussion, something else began to happen as well. People began to think deeply about what it would actually mean if we were not alone. For most of human history, the Earth felt like the center of everything. Ancient civilizations believed the sky revolved around our world, and that humanity held a unique place in the structure of the cosmos. But over the centuries, science slowly reshaped that perspective. First, we learned that Earth was not the center of the universe, but only one planet orbiting the Sun. Later, we discovered that the Sun itself was just one star among hundreds of billions within the Milky Way galaxy. And now we know that there are billions of galaxies beyond our own. With each discovery, humanity's place in the universe grew smaller, but also more connected to something far larger. The possibility of alien life is the next step in that long unfolding realization. For many people, the thought is exciting. The idea that other intelligent beings might exist somewhere among the stars sparks curiosity and wonder. It suggests that life is not a lonely accident, but part of a much larger cosmic story unfolding across the universe. Scientists, philosophers, and artists alike often imagine what such civilizations might be like. What would their cultures be like? Would they have music, language, and art? Would they experience curiosity and imagination the same way humans do? Or would their ways of thinking be so different that we might struggle to understand them at all? These questions touch something deep within human nature. We are naturally curious creatures. From the earliest days of our species, people have looked at the night sky and wondered about the light scattered across the darkness. Those distant points of light inspired myths, stories, and eventually scientific exploration. The search for alien life is, in many ways, an extension of that ancient curiosity. But the idea can also create a sense of uncertainty. Some people feel uneasy imagining civilizations far more advanced than our own. Science fiction has often explored these fears, telling stories of alien visitors, mysterious technologies, and encounters between very different worlds. These stories reflect a natural human instinct to be cautious about the unknown. Yet many scientists believe that if intelligent civilizations do exist, they are likely separated from us by enormous distances. Even traveling at the speed of light, communication between stars can take decades, centuries, or longer. The universe is vast beyond anything our minds easily grasp. Because of this, any contact between civilizations would probably unfold slowly, through faint signals, distant observations, and careful study rather than sudden encounters. In fact, some scientists think the first evidence of alien life may not come from intelligent beings at all. Instead, it may come from microbial life on another world. Imagine a future telescope studying the atmosphere of a distant planet. Within the faint light reflected from that world, scientists detect unusual gases, perhaps oxygen and methane appearing together in ways that cannot easily be explained by geology alone. Such a discovery might suggest the presence of living organisms quietly shaping the chemistry of their planet. Even finding simple life elsewhere would be an extraordinary moment in human history. It would show that biology is not unique to Earth, that the universe itself has the ability to generate living systems in many different places. And that realization might change the way humanity sees itself. Rather than being alone in a silent cosmos, we might come to understand that life is woven throughout the fabric of the universe. Many philosophers have suggested that this realization could bring a new perspective to human civilization. If life exists across many worlds, then Earth becomes something even more precious, one example among countless others of a rare and fragile phenomenon. A small living oasis drifting through the vast darkness of space. Looking up at the stars then becomes something slightly different. The night sky is no longer just a field of distant suns. It becomes a landscape of possibilities. Each star might host its own collection of planets. Some barren and frozen, others warm and ocean-covered, perhaps even home to strange ecosystems evolving beneath alien skies. And somewhere, perhaps far beyond the reach of our current technology, there may be other minds wondering about the same questions. Other beings looking up at their own night sky, seeing our sun as just another distant star. Perhaps they too are asking whether life exists beyond their world. Perhaps they too are listening quietly, hoping to hear a faint signal from another civilization across the cosmic ocean. For now, the universe keeps its silence. But that silence does not feel empty. It feels full of possibility. And every generation of scientists, explorers, and dreamers continues looking outward, studying the stars, building new instruments, and expanding humanity's understanding of the cosmos. Because somewhere within that immense darkness, answers may be waiting. Answers about life, about intelligence, and about the place our small blue planet holds within the vast story of the universe. As people imagine the possibility of alien civilizations, one of the most common questions quietly follows close behind. If we ever discovered that intelligent life exists beyond Earth, would those beings be peaceful, or would they be a threat? It is a natural question. Human history itself has often been shaped by encounters between different cultures. Sometimes those encounters led to cooperation and learning. Other times they brought conflict, misunderstanding, and fear. Because of this, many people instinctively wonder whether contact with another intelligent species might carry similar risks. But when scientists think about this possibility, they often begin with a simple observation. The universe is incredibly large. Even the nearest star system beyond our own, Alpha Centauri, is more than 4 light-years away. That distance may sound small in cosmic terms, but in practical terms it is enormous. Our fastest spacecraft would take tens of thousands of years to travel that far. For any civilization to cross such distances, it would likely need extremely advanced technology and vast amounts of energy. And that leads to an interesting thought. A civilization capable of traveling between stars might also be a civilization that has already solved many of the problems that cause conflict, problems like resource scarcity, environmental collapse, or technological instability. Some researchers suggest that any society advanced enough to explore the galaxy may have already passed through long periods of social and scientific development. Over time, they may have learned how to manage their resources, cooperate with one another, and sustain their civilization over very long timescales. If that is true, then such a civilization might be more curious than aggressive. After all, interstellar exploration would likely be motivated by knowledge and discovery rather than conquest. The energy required to travel between stars would far exceed the resources available on most individual planets. It would often be far easier to gather materials from asteroids or uninhabited systems than to attempt conflict with another intelligent species. In this sense, the universe may encourage exploration rather than competition. There is also another important factor. Space itself acts as an enormous barrier. Distances between civilizations would likely be so vast that direct encounters would be extremely rare. Even if intelligent species existed elsewhere in the galaxy, they might remain separated by thousands or even tens of thousands of light-years. Communication alone could take centuries. Because of this, the first contact between civilizations would most likely occur through signals rather than physical visits. A faint radio transmission. A repeating pattern detected by a telescope. Or perhaps an unusual technological signature observed from a distant planet. Such discoveries would unfold slowly, giving humanity time to study and understand what we are seeing. Some scientists even believe that the first alien intelligence we encounter may not be biological at all. It could be a form of artificial intelligence created by another civilization long ago. Such systems might explore the galaxy slowly, traveling from star to star over thousands or millions of years, gathering information and sending data back to their creators. These probes might observe planets quietly without interfering, much like robotic explorers studying environments on Earth. Another interesting idea is that advanced civilizations may deliberately avoid interfering with younger species. This possibility is sometimes described by the cosmic zoo hypothesis, which suggests that older civilizations might observe developing worlds like Earth without revealing themselves, allowing life to evolve naturally without outside influence. In this scenario, intelligent beings across the galaxy might follow a kind of ethical guideline, avoiding direct contact until a civilization becomes technologically mature enough to understand the wider universe. Of course, these ideas remain speculative. The truth is that we simply do not yet know what other forms of intelligence might be like. Alien life could be peaceful, curious, indifferent, or something entirely beyond our current imagination. Their motivations might depend on their biology, their environment, and the long path their civilization followed through history. But many scientists emphasize one important point. The search for alien life is not primarily about danger. It is about understanding. Discovering life elsewhere would expand humanity's knowledge in ways almost impossible to predict. It would show us that biology, evolution, and perhaps even intelligence are natural parts of the universe. It would mean that Earth is not the only place where the cosmos has learned to observe itself. And that idea carries a quiet sense of wonder. Because somewhere out there, across the vast darkness between stars, another civilization might be asking the same questions we are asking tonight. Looking up at their sky. Watching distant stars drift slowly across the night. and wondering whether somewhere in the universe, another world filled with oceans and forests might also be alive, and looking back. As scientists continue thinking about alien civilizations, they often return to one quiet but powerful idea. The universe has had an enormous amount of time to experiment with life. Our galaxy alone formed more than 13 billion years ago, while Earth is only about 4.5 billion years old. This means that many planets in the Milky Way may have formed billions of years before our own world even existed. If life arose on those ancient planets, evolution may have had a tremendous head start. Some alien civilizations, if they exist, could potentially be millions or even billions of years older than humanity. It is difficult for us to imagine what such long stretches of time might allow a civilization to achieve. Human technological society has existed for only a few hundred years. In that brief period, we have gone from simple mechanical machines to satellites orbiting our planet and robotic probes exploring other worlds. Now imagine that same process unfolding not for centuries, but for millions of years. Some scientists believe that advanced civilizations might eventually learn to reshape their planetary systems. They could move asteroids, build enormous habitats in space, or harvest energy directly from their stars. Others imagine that such civilizations might gradually spread across their galaxy, sending small robotic explorers to neighboring star systems. These probes could replicate themselves using materials found on asteroids, slowly expanding outward over thousands or millions of years. In theory, a self-replicating exploration system could eventually reach large portions of the galaxy. This idea is sometimes called a von Neumann probe, named after mathematician John von Neumann, who studied machines capable of copying themselves. If such probes existed, they might quietly travel between stars, collecting scientific data and transmitting information back to their creators. Yet despite these possibilities, the sky remains strangely quiet. This brings us again to the famous Fermi paradox, named after physicist Enrico Fermi. One day in the 1950s, while discussing the possibility of extraterrestrial life with colleagues, Fermi reportedly asked a simple question: "Where is everybody?" If intelligent civilizations are common, and if the galaxy has had billions of years for exploration to occur, then why do we not see clear signs of them? There are many possible answers. One possibility is that intelligent life is extremely rare. Perhaps the chain of events that led to life on Earth is far more delicate than we currently understand. Another idea is that civilizations may simply be too far apart. The galaxy is vast, and even advanced technologies might struggle with the enormous distances involved. Some researchers suggest that many civilizations may focus inward rather than outward. They might develop virtual environments or internal technologies that reduce the need for large-scale space exploration. In other words, once a civilization becomes sufficiently advanced, it may lose interest in expanding across the galaxy. There is also the possibility that we are simply very early in the history of intelligent life. Although the universe is old, many stars, especially long-lived red dwarf stars, will continue shining for trillions of years. Compared to that immense future, humanity may exist near the very beginning of the cosmic timeline. If that is the case, intelligent civilizations may become far more common in the distant future than they are today. In a way, humanity might be among the early observers of the universe. Another fascinating discovery in recent decades has been the detection of exoplanets, planets orbiting other stars. Before the 1990s, scientists were not even certain whether planets were common beyond our solar system. But modern telescopes have now discovered thousands of exoplanets, many of them Earth-sized and located within the habitable zones of their stars. Some of these planets may have oceans. Some may have thick atmospheres and active weather systems. A few might even resemble the early Earth. Future telescopes will be able to analyze the light passing through the atmospheres of these distant worlds. By studying that light, scientists may detect the chemical fingerprints of life. Gases like oxygen, methane, or other biological byproducts. If such signals are found, they would provide strong evidence that life exists somewhere beyond Earth. And that discovery could happen within our lifetimes. Until then, humanity continues its quiet search. Radio telescopes listen patiently for signals. Space probes explore the planets and moons of our solar system. Astronomers examine distant stars, searching for subtle clues hidden in the faint light of distant worlds. Each observation adds another small piece to the puzzle. And as the night sky stretches endlessly above our planet, it reminds us that the universe is still filled with mysteries waiting to be understood. Perhaps somewhere among those distant stars, life has already begun its own journey of discovery. Looking outward, asking questions, and wondering, just as we do, whether other minds exist in the vast darkness between the stars. As astronomers have continued studying the sky with increasingly powerful instruments, one of the most surprising discoveries has been just how common planets actually are. For most of human history, we only knew about the planets in our own solar system. But in the past few decades, telescopes like the Kepler Space Telescope have revealed something extraordinary. Planets are everywhere. In fact, scientists now estimate that the Milky Way galaxy alone may contain hundreds of billions of planets. Many stars appear to have entire planetary systems orbiting them, much like our own Sun. Some of these worlds are small and rocky, similar in size to Earth. Others are enormous gas giants many times larger than Jupiter. Some orbit extremely close to their stars, completing an entire year in just a few days, while others drift in distant, cold orbits far from their suns. Among these discoveries are planets located within what scientists call the habitable zone. The region around a star where temperatures might allow liquid water to exist on a planet's surface. Water, as far as we know, is one of the most important ingredients for life. Because of this, astronomers pay special attention to these worlds. One of the most intriguing planetary systems discovered so far is called TRAPPIST-1. This small red dwarf star, located about 40 light-years away from Earth, has at least 7 rocky planets orbiting it. Several of those planets lie within the star's habitable zone, and some may even have oceans. Although we cannot yet see the surfaces of those distant worlds directly, future telescopes may be able to study their atmospheres in detail. And somewhere within those faint signals of light, there may be clues about whether life exists there. Another fascinating observation comes from the chemistry of space itself. Astronomers studying interstellar clouds have discovered that organic molecules, the basic components used to build life, are surprisingly common throughout the galaxy. These molecules form naturally in cold clouds of gas and dust between the stars. Over time, those clouds collapse to form new stars and planets, carrying their complex chemistry with them. This means that many young planets may begin their existence already surrounded by the building blocks needed for life. In other words, the universe may be chemically prepared for biology long before life actually appears. Closer to home, our own solar system may still hold important clues. Several moons orbiting the giant planets appear to contain hidden oceans beneath their icy surfaces. Jupiter's moon Europa, for example, is believed to hide a vast ocean of liquid water beneath its frozen crust. Tidal forces generated by Jupiter's gravity may keep that ocean warm enough for liquid water to exist. Similarly, Saturn's moon Enceladus has been observed ejecting plumes of water vapor into space from cracks in its icy surface. These plumes contain salts and organic molecules, substances that hint at complex chemistry occurring within its hidden ocean. If microbial life exists anywhere else in our solar system, these underground oceans may be among the most promising places to search. Future space missions are already being planned to explore these worlds more closely. But beyond planets and moons, astronomers are also studying the strange signals that sometimes arrive from deep space. One particularly mysterious phenomenon is known as fast radio bursts, or FRBs. These are extremely brief but powerful bursts of radio energy that appear suddenly from distant galaxies. Each burst lasts only a fraction of a second, yet during that brief moment it can release more energy than our Sun produces in an entire day. Most scientists believe FRBs are produced by exotic cosmic objects such as magnetars, neutron stars with incredibly strong magnetic fields. However, because the signals are so unusual and energetic, they have occasionally sparked speculation about whether advanced technologies might produce similar phenomena. So far, no evidence has linked FRBs to alien civilizations. But studying them continues to deepen our understanding of extreme astrophysical processes. And perhaps most importantly, it reminds us how many mysteries the universe still holds. Every year, new telescopes reveal phenomena that scientists had never seen before. Entire categories of cosmic objects, strange stars, unusual galaxies, and unexpected signals continue to appear in our observations. In this way, the search for alien life is part of a much larger journey. It is the journey of understanding the universe itself. Each discovery, whether it is a distant planet, a hidden ocean beneath ice, or a mysterious burst of energy from a faraway galaxy, expands our view of what the cosmos might contain. And slowly, as our knowledge grows, the question of life beyond Earth becomes less about imagination and more about careful exploration. Somewhere among the countless stars of the Milky Way, there may already be worlds where life has taken root. Perhaps simple and microscopic, perhaps vast and complex, or perhaps intelligent beings quietly studying the same universe we are only beginning to understand. And as humanity continues to watch the sky, build new telescopes, and send new probes into space, the answers may slowly begin to reveal themselves, hidden among the faint lights that drift across the night. And as we slowly reach the end of this journey together, the universe grows quiet again. The questions remain, of course. The stars still shine in distant silence, and the enormous galaxies continue their slow motion across the vast darkness of space. But sometimes the most peaceful part of science is not the answers we find, it is the sense of wonder that stays with us afterward. For thousands of years, human beings have looked upward. Long before telescopes existed, people stood beneath the night sky and watched the stars drift slowly overhead. Ancient travelers used them to guide their journeys. Storytellers wove myths around them. Philosophers wondered whether other worlds might exist beyond the faint light scattered across the darkness. And now, many centuries later, our understanding has grown deeper than those early dreamers could have imagined. We know that the stars are not small lights in the sky, but enormous suns scattered across a vast galaxy. We know that many of them have planets, some hot and violent, others quiet and ocean-covered. We know that the ingredients for life exist throughout space, drifting inside cold clouds of gas long before planets even form. In a way, the universe itself seems to be gently experimenting with life. Across billions of years, atoms come together, forming molecules, oceans, ecosystems, and eventually creatures capable of wondering about their own existence. On our small planet, those wandering creatures became us. And now, we sit quietly beneath the same sky that fascinated our ancestors, asking the same timeless question. Is anyone else out there? Perhaps somewhere in the distant arms of the Milky Way, another world orbits a quiet star. Maybe that planet has oceans that glow softly beneath an alien sky, or forests growing under a different kind of sunlight. Perhaps life there has evolved in ways we cannot yet imagine. And perhaps, on that distant world, another civilization is beginning its own journey of discovery. Maybe they have built telescopes and turned them toward the stars. Maybe their scientists are studying the chemistry of distant atmospheres, searching for the faint signs of life beyond their planet. Maybe they too are wondering whether they are alone. If that is true, then the universe is not just a vast emptiness filled with silent stars. It is a place where curiosity slowly awakens on scattered worlds. Where thinking beings emerge from oceans and forests and deserts, look upward, and begin asking questions about the cosmos that created them. For now, the distances between those worlds remain enormous. The signals we send into space travel slowly, spreading outward through the galaxy like faint ripples in a cosmic ocean. It may take centuries, or thousands of years, before those signals reach another civilization. If they ever do. But the act of searching itself is meaningful. Every telescope we build, every spacecraft we launch, every observation we make brings us one small step closer to understanding the universe and our place within it. And perhaps that is the quiet beauty of science. It is not just about solving mysteries. It is about learning to see the universe more clearly. So tonight, as you rest and let your thoughts drift gently like distant stars, imagine the vastness of the cosmos stretching far beyond the limits of our imagination. Billions of galaxies. Trillions of stars. Countless worlds drifting silently through the darkness. Some cold and empty. Some perhaps filled with oceans and strange ecosystems beneath unfamiliar skies. And somewhere among them, perhaps very far away, another mind may be looking outward just as we are, wondering about distant planets, distant civilizations, and the quiet possibility that life is not alone in the universe. For now, the stars keep their secrets. But they shine patiently above us, night after night, reminding us that the universe is far larger and more mysterious than we once believed. And as humanity continues its slow exploration of that vast cosmic ocean, the story of life, our life, continues to unfold among the stars. So rest now, and let the universe drift softly through your thoughts. The stars will still be there when morning comes.